Oh yeah.
Oh yeah.
Hand in your assignment 3. Gimme, gimme. Should I just walk around and grab them? Coming around. To be quite honest, I'll probably just look at the total amount of interest paid, and if it's right, I did it. Top notch. So I'll have those back for you on Thursday so that you can use them to study. I have to start this again. Okay. So today, so you've got your test 3 back. I've got your assignment 3s. It's almost like the semester's wrapping up. Well, hey, you and me both. You and me both. I'm freaking out. All right. So what we're going to do today is the beginning. I'm going to go through, there's going to be short answers. Of course, I'm not going to go into the nitty-gritty of those. You've seen all the short answers. There's not going to be any short answers on mortgages. So it'll be from test 1, 2, 3, those types of questions. Okay. But what I do want to talk about is just very specifically for those long answer questions, what type of question to expect, right? So that you can focus your studying. I posted the practice final on Moodle. I didn't bring you printed copies because I'm pretty sure I made it with all the spacings. And so it would have been a lot to print and for a lot of people to not show up. Anyways, that's how I end up with too much paper. So, final exam review. Yikes. Makes me sad. You guys are really fun, so. I know you're not sad for it to be over. All right, so just the general format is going to be, so there's going to be 20 marks of short answer. Right, and by now you have a pretty good idea of the types of questions we've got for these short answers, right? Test 1, test 2, test 3, you've all had short answers, so you kind of know what to expect. Most of them are 1 marks, some of them are 2 marks, right? So it's not necessarily 20 questions, but just kind of 20 marks of short answers. Okay? The total is going to be 110, so probably focus on the long answers. 90, yeah, there's going to be 9 long answer questions. So 9 long answer questions. And they're 10 marks each. So same as specifically test 3, right, where some of them were way easier than the other long answers, but they're all worth 10 marks, right? So if we go through this list and you say, oh, okay, well, I've got that one in the bank, that one in the bank, that one's going to be a little bit trickier, right? Then maybe just focus on those ones that you know you've got a handle on, right? Lock those down. and then just kind of sort through the rest. So, all right. Let's talk about these long answers. So the first one, and what you'll notice is we're just going to work through our formula sheet. Okay, so there's going to be, the first long answer is going to be on merchandising back in test 1. Oh, I think you'll be happy to know that there are no linear programming questions on the final. I know.
Yeah, but what about chapter 1?
Merchandise?
I don't know.
Oh, one that was hard? I don't know, you tell me.
Just put letters, switch them around.
Maybe that's merchandising, we'll see. But so the first long answer is going to be on merchandising. And so that's where we had the selling price, the cost, the profit, right? The overhead expenses, all those things. And we had to answer some questions, right? So merchandising, so we saw that on test number 1. The second long answer is going to be Cbp analysis, which you might remember your favorite profit function. So profit functions, okay, which was also on test number 1. So that's the second section on your formula sheet, right, where you have to build some profit function. So I give you information, you have to build the profit function, and then answer things like, what's the break-even point? What's the shutdown point, right? If you want to make this much profit, how much do you have to sell, etc.
Are we getting that exact same formula sheet for?
So in the final, you'll have, just like all the tests, I'll just put it into the exam, you'll have it, and it'll be the exact same one as we've got this whole time. Oh, one thing about your final, it's in S104. So in the student services building, there's that huge auditorium, and we're sharing it. So it's our section, my other section, Steve's section, and Steve's other class.
It's not actually a classroom.
It's like, yeah.
Building.
So think auditorium seating. It's really not that great for writing a final because you've just got that little table on the side. I can't, there's nothing I can do. I know. And so what's going to have to happen is we'll send out a note ahead of time so you know where you'll be sitting, and then hopefully that'll kind of alleviate some stuff when we get there.
Be on like the benches around. It's gonna be
In the seating. Yeah. So, oh no, in the, so on the side there, there's like a theater. We're in the theater. It's like a secret huge theater that they've got. Yeah.
It sucks.
The chairs are comfy, so maybe that's something, right? Yeah, definitely bring earplugs. Maybe keep in mind that going to the washroom is going to be a lot of like, excuse me, coming through, sorry. So keep that in mind. Okay. Question 3. Simple interest. Surprise, surprise. Just one long answer on simple interest. Which we saw on test 2. Then we're going to move into compound interest. There's actually going to be 2 questions on compound interest. Okay. The first one, I make you find an unknown payment amount. And then the second one, I make you have to do it by hand. Okay. there's going to be 2 questions on here that you have to do by hand. So one compound question and one annuity question. Okay. So the first one is on compound interest. Where you have to find an unknown payment amount. Which we saw on test number 2 as well. The next one is a compound interest problem that you have to do by hand, right? So compound interest, we can use our calculator, so you're welcome to check your answers using your calculator, but all your work that you do has to be shown by hand. Okay. So compound interest, oops, dropped an E. Solved by hand. Which, depending on how you did test 2, maybe that is exactly like how you did test 2 if you did it all by hand. We didn't really love our calculators back then, so you've probably already done it by hand. Test number 2. Yeah. Then we go to the next page, which is going to be an annuity question by hand. So it's the only annuity one that you have to do by hand. The other ones, you're welcome to use your calculator. So it's an annuity question, and you have to solve by hand. Which you had on test 3. On the plus side, it's not going to be nearly as hard as the one I made you do on test 3, right? You are going to have to do that type of problem with a twist. I'll talk about it in a sec. But you can use your calculator, which makes it a lot easier, right? So an annuity, I'm not going to write it down, but I'll tell you, you're either going to have to calculate a future value or a present value. Right. For 6, or yeah, depending on how you, for the solve by hand one, right? So you don't have to find n or anything weird like that, right? It's either going to be present value or future value, right? Either it's a due or just an ordinary annuity, right? But so nothing too crazy. Here's where we get a little crazy. So the next one, you can use your calculator, and I would encourage it, is going to be an annuity question. It's going to be a 3-part annuity. So remember that last question on the test that you just did? I would call that a 2-part annuity. Now imagine that there's some space in between those 2, right? So we're making payments, and then we let it sit for some amount of time, and then we're getting payments, right? So it's got this little chunk of compound interest in there. Fun. But you can use your calculator. So you can do it. And like I said, we'll go through the practice test. We won't have time to get to that question until Thursday. So yeah. I think we just got through compound interest yesterday, so I would expect that 6 onward we'll do on Thursday instead, just as a heads up. Because I know it's a busy time, so if you feel comfortable with that and you don't want to stick around, then that's okay. So it's going to be another annuity question where you can use your calculator. And it's going to be a 3-part So where we have some where we're probably making payments, and then let it sit, and then we're getting payments. And there's an example on the practice final, of course. Of course. Another annuity. Question 8 is another annuity. Where again, you can use your calculator. Making it much nicer. This one's going to be 2 parts. It's a 2-part question. Oh, the 3-part one, I'm going to say sort of like on test number 3. Right, just adding in that chunk of time, right? Because he was making, Ernie, I think it was making payments, and then immediately he went to getting payments, right? We're just going to put a little gap in there. So this one's going to be 2 parts, and it's going to be that deferred annuity that we looked at, but we only saw it in class. I can only put so many questions on the test. So, so we have some amount that we've invested, right? And then we let it sit for some amount of time until we can get some set payments, right? And we want to know how long do we have to wait until we can get these payments. Okay. So it's going to be a deferred annuity. And you have to solve for time. And we did one of these in class. Last but not least, probably after this written assignment, everyone's favorite question. Once you kind of get the hang of it, it's pretty fun, is on mortgages. But like I said, this is the exact same layout that you can expect on the final, right? Find the payment amount, fill in this table. Right? As long as you filled in the table correctly, that would be full marks. Here, I wanted to see kind of what work you did, and then find the total interest paid. So those are the parts that you can expect to see. Right? And so a mortgage question, which was on written assignment 3. Which I'll hand back on Thursday so that you have them. For a total of 110 worth every minute marks. Oops, can't write marks. 3 hours. So, any questions about the format? Nope. All right. Probably kind of what you were expecting. Got to touch on every subject. No ifs, ands, or buts about it. Oh, as far as office hours go, I'm available, of course, anytime. Online or email, text me, whatever. Okay, so you guys are the 002s. So office hours. Most importantly, probably, is that I'm gonna have all day office hours on the day of the exam because we're not until 6. Right, so I'll be there 9 to 5. Kind of, I know that's when you'll have questions for me. So all day, December 18th, from 9 to 5. Only because I need to go get set up for the final at 6. And you guys should probably take a break. Anyways. In the afternoon of December 17th, I don't know, kind of after, probably 2. My flight is supposed to get in at 12:30, and so that's why I'm kind of like, yeah, could be winter time after 2 sometime, okay? But always, and then I'll have office hours on the 11th and 12th as well, but if you want to know those, then just let me know. But otherwise, available anytime, and I mean anytime, by text 250-864-8386. So if you're ever working on a problem and you're like, hey, what's going on here? Probably easier to just send me a picture of what you've done. Maybe include the question in there because I don't have them all memorized. And then I can help you out, or by email. And it's just Lee, so many E's, at okanagan.bc.ca. So I'm available all the time, in-person office hours, the day of and the day before. Okay, cool. Even if you prefer to just meet in Zoom, that works for me too, right? If you're working at home or whatever. Okay, cool. So you've got options. Let's do this practice final, shall we? Any questions before we do? We are definitely going to start with the long answers. What's likely going to happen is that we won't have time to get through the short answers, but I'll post the solutions, of course, and then so you'll have them, but I'm going to focus on the long answers. So let me just steal this. Oh. I don't want to delete it. I want to move it. I like to move it. The numbering got weird because each of the short answers was has a number. So anyways, it doesn't matter. Oh, and in case you haven't cracked the code yet, the number in the square or in the square brackets, that's the number of marks, right? So especially if you're looking at those short answers, then you'll know how many marks each of them are. Here we go. And don't worry, the list that we just went through, that is the order that they'll be in. Right, I'm not trying to trick you here. Right, so if you remember, okay, I want the third one, just go to that one. Right. And so this is going to be a merchandising question. Right? First thing on the formula sheet. So let's see if we remember our merchandising stuff. Looks like Greek to me, huh? An RV dealer purchases stock for $138,423, less a discount of 39%. The dealership marks up 25% of cost for the overhead and 35% of selling price for profit. During a sale, this particular model of, I'm going to go ahead and say it was an RV. It really doesn't matter. But because it's an RV dealership, I'm going to assume model of RV was advertised at $119,995. Determine the cost, the selling price, and the rate of the markdown during the sale. Okay. So there are three things that we need to find. Right? And so, all right. Whenever I give you a list of things to find, it's safe to say that I want you to find those, or it's going to help you if you find those in that order. Right?
Oh, okay.
I'm not trying to throw you for a loop, right? Once you have the cost, it'll be easier to find the selling price. And once you have the selling price, it'll be easier to find the rate of the markdown. Okay. So let's write down what we have, and then we can kind of go from there. So we've got a list price of $138,000. Yes. So the list price, remember, is whatever the cost was before the discount, but because we're getting a discount of 39%, right, that 138 must be the list price. And then once we've reduced it by 39%, that's going to be our net price, right? So L must be 138,423. We're told that the discount is 0.39. And there's just one discount, so we just use a lowercase d. And we have, okay, so the dealership marks up 25% of the cost for the overhead. Remember the overhead, we use E as the notation, right? Expenses. Mostly because using a capital O looks like 0 and it gets confusing. Yeah. And so we've got E, where should I put it? Well, I'll just put it here. E is going to be 0.25 of the cost, C. And the selling, so 35% of the selling price for profit. So we know that P must be 0.35 of the selling price, S. Mine too. It's a flaw. But I'm going to blame it on S and 5 looking similar, not our writing. And then, so now it goes on sale, and now we've got this reduced selling price of 119,000. So we use S subscript R, 119,995. And we want to find cost, selling price, and I'll just abbreviate ROMDA, the rate of the markdown. Right, our cost is C and selling price is S. So we kind of have to dust off all these variables, right? E, P, C, S. Right? Remember what all those are. So the cost, let's deal with the cost first. So the cost to the dealership, right? That's how much it costs them to get this RV on the lot, right? And so we're told in the beginning that, okay, well, an RV dealer purchases stock for $138,000 less 39%, right? And so the net price is the same as the cost on the dealership level. Okay? So we're going to find the cost, which is the same as the net price to the dealer. So we're going to use N is L times 1 minus D. from our formula sheet. The tricky part, right, is remembering what the net price is and then seeing that, okay, well, the net price is the same as the cost to the dealer. So 138,423. Thank you. I'll just Martha Stewart it. 84,438.03. Because I've used this practice final before, so got it all ready to go. Oh. So, therefore, C is also 84,438.03. So we have now found the cost. So let's see what we've got. So now, in addition to all these things, we've got the cost. And if you look at your formula sheet, if you want to know S, we've got two options, right? S is the cost plus the markup. We don't know the markup, we could find it, right? No problem. Or we can just jump straight to S as the cost plus the expenses plus the profit. We have C, we have E, and we have P, right? So let's just use that one. So find S. S is the cost plus E plus P. What I'm going to do is I'm going to keep all of these in terms of the variables. So even though we know the cost, I'm going to keep it as C because E is 0.25 times C. So that way I'll be able to collect like terms. I'm just going to minimize the math that I have to do. Okay. So E is 0.25 C and P is 0.35 S. So we can say, okay, well then S must be C, which is just C, plus 0.25 C plus 0.35 S. So now I only have two variables. I have S and I have C, but I know what C is. So first thing I'm going to do is I'm going to move the S over. There's lots of ways that you could go about doing this, right? As long as you get the same S that I do, you did it. So I'm going to do S minus 0.35 S is C plus 0.25 C. So we get 0.65 S, right? 1 minus 0.35. 0.65 and is 1 plus 0.25, 1.25 C. Now I'm going to plug that C in. If you prefer to just plug the C in right away and get rid of that variable, that works, right? Like I said, there's lots of ways that you could go about doing this. So we've got 0.65 S is 1.25 times C, which we said was 84,438.03. So 1.25 times 84,438.03. 105, 547.5375 is 0.65 S. So now we have to divide both sides by 0.65. So we get S is 105. I'll show all my steps here. So I get $162,380 and 8269 pennies. Therefore, S is 162,380.83. So now we have S, and the last thing we want to do is find the rate of the markdown. Glancing at your formula sheet, you have two options. I'm going to use the first one, right? The reduced selling price, I know that. I know the original selling price, and then I can solve for the rate of the markdown, right? You could use the other one. The rate of the markdown is D over S. D is the amount of the markdown, so you would have to find that first and then divide it by S. That's okay. You should arrive at the same thing. So finally, we're going to find the rate of the markdown. We can use SR is S times 1 minus the rate of the markdown, or the rate of the markdown is D over S. I'm going to use the first one just because it's less math. How do you find the amount of the discount? D. That's going to be the 162 minus 119,000. Because it's a selling price minus the reduced selling price. That's the amount of the discount. And that's how you would find D. Right? But I will use SR is S times 1 minus the rate of the markdown. I guess I'll write it out again. SR is S times 1 minus the rate of the markdown. SR was 119,995. Is that right? Yeah. Is equal to 162,380.83 times 1 minus the rate of the markdown. So we need to divide both sides by 162,380 and 83 pennies. 119,995 divided by 162,380.83. I'll show my work. You don't have to. But that's going to be the rate of the markdown. If you just went straight to 0.7389, oops, 3897.2698 is 1 minus the rate of the markdown. Works for me. We have to subtract 1 from both sides and then ditch the negatives. So you want 0.738972698 minus 1 is the negative rate of the markdown. This becomes negative 0.261027302 is the negative rate of the markdown. Technically, we're dividing both sides by -1, but you can just cancel those guys out. So therefore, the rate of the markdown is 0.261027302, or 26.1%. Everything is so dry. I'm like, cool, we did it. Merchandising, ring a bell? Yeah. Yeah. Okay. So Sure is. So I'll actually just make a little note here that this is Cbp Analysis. And I'll make a note above the first one that this is merchandising. Just so you know. All right. So Walmart plans to sell 200 barbecues next week at an average cost of $278 each. Their weekly staffing expenses are $1,945. Sounds a little low. Anyways, so we've got this cost. So what we mean by at an average cost, so that's the cost for them to buy this barbecue, right? For them to bring in this barbecue, that's the cost. And so, and then we've got some expenses, right? These are fixed expenses because it doesn't matter how many barbecues they sell, they have to pay their staff no matter what, right? So that would be a fixed cost. And so we're told that they're going to sell 200 barbecues. And then how much must they charge for each barbecue to break even? And so what we'll first do in this part, and what you'll notice is that this part is going to be worth quite a bit more just because you have to develop the profit function. And then once you have the profit function, you can use it for the rest of the parts. And so remember building our profit functions, we start down here at the profit, and then we kind of snake our way through the formula sheet and build up our profit function. Right? So first we're going to find the profit function. Just making a little note to myself here. So the profit of X, remember, is the number of barbecues sold. So the profit of X in general is the total revenue minus the total cost. Just starting there on our formula sheet. And then we can look up and say, okay, well, the total revenue, I can actually replace it with P times X. P is the price that we charge per barbecue, and X is the number of barbecues that we're selling. So we'll swap total revenue with P times X. And the question in the end is asking how much must they charge? So really we're just finding P, right? How much do we have to charge to break even? Minus the total cost. The total cost is the variable cost plus the fixed cost. So we have PX minus, and then in brackets, the variable cost plus the fixed cost, because that TC, so we have to, I don't want you to forget those brackets, or if you do, then expand that negative in onto the fixed cost as well. Which is PX minus, and we know that the variable cost is the cost. So the cost to acquire one of these things or to make one of these things times however many we need, X, plus the fixed cost. Huh? So now we can expand these, expand the negative into the brackets, and we can say, okay, well, that's the same as PX minus CX minus the fixed cost. I saw a lot of kind of mishaps on test one where you got to here and then you forgot to bring that negative onto the fixed costs, right? Makes a big difference. Now we can collect like terms if you want. The P is multiplied by an X, the C is multiplied by an X. So we can pull the X out front, X times P minus C minus the fixed costs. All of this is true for any profit function. Right? So none of this is question specific. Right? You can just use that to develop your profit function. And then, because in here, there's things that we know, right? We want the profit function, and we know that they're going to sell 200 barbecues. We want to figure out what they have to charge to break even. Now we have to remember, okay, what does it mean to break even? It means that we have zero profit, right? So then on this side, we have to have zero. Right? We're solving for P. We know the cost to them is $278, right? The cost per barbecue. And then the fixed cost is what they have to pay their employees, right? The $19.45. Obviously, the real Walmart would have way more to pay. Rent, taxes, whatever. But that's the information that we have. Is that a question, Stretch? Or got it?
That 6 lines of manipulation worth marked. Can we just go P minus C times X minus FC?
No, you can go straight to it. Yeah. You can go straight to it. As long as you're confident it's right. Yeah. So if you wanted to go straight to here and tell me profit of X is X times P minus C minus FC, that's fine. Right? Because the question really is just asking, how much do they have to charge to break even? Right? To answer that, we need the profit function. Right? But that's the only reason we're doing it. Yeah. So I'm going to make a note here that break even is when profit equals 0. And so we've got, just in general here, profit of X just transferring, I guess where you could start if you wanted to. So now we're saying, okay, I'm going to force this profit to be 0. X I know is 200 from the question, right? They know they're going to sell 200 barbecues next week. How, I have no idea, but whatever. P is what we're trying to find. The cost is 278 minus the fixed cost of 1945. Right. So you'll be given a blurb and you have to identify, okay, what's the cost? Do I know the price? Do I know X? Right. So now we have to shake out that P, so we have to add 1945 to both sides. Is 200 times P minus 278. Then we have to divide both sides by 200. 1945 by 200. I'll show the steps in this one, but because we're going to do it lots of times, then later I'll skip some of these steps. P minus 278. 1945 divided by 200. 9.725 is P minus 278. So I have to add 278 to both sides. 9.725 plus 278 equals P. P must be 287.725. So they must charge 287.73 to break even. As far as your answers go, you don't have to write the blurb, right? They must charge blah, blah, blah to break even. If you get to P and you leave it, that's fine by me. I'll just be looking for that number anyways. I'll be so desperate to finish marking at that point. As long as you have the answer somewhere, you'll probably get the mark. So, hard part, I'd say, is done for that question, because now, part B, we want to know, okay, fine. If they wish to make a profit of $1,500, what price do they have to charge? That sounds familiar. Right? So now we can just steal that profit function from where we put in 0. Right? Instead of 0 profit, now we want 1,500. But besides that, nothing's changed. Right? We're still selling the same amount, and we want to know what they have to charge to make this amount of profit. Right? The costs and the fixed costs are all the same. So we've got I'll write out my general one. You don't have to, but I want this to be 1,500. I'm still selling 200. I'm trying to find P. The cost is still 278 minus the fixed cost, which is still 1945. So now this is where I'm going to skip some steps in showing my work, right? So I'm going to do 1,500 plus 1945. I get 3445 is 200 times P minus 278 divided by 200. I get 17.225 equals P minus 278. So P must be 17.225 plus 278. 295.225. Therefore, they must charge $295.23 for a profit. Too much writing. Of 1,500. Let's steal this next one. Same idea, but new information for part C. Right. So now if they sell 90 barbecues, so not 200 anymore, right, at $400 each. So now I'm telling you, okay, this is the price. Okay. How much profit will they realize? Now we can solve for the profit instead, right? Here's a new scenario. Figure out the profit. So I'm going to use that general profit function. So if you've got it memorized, great. If not, that's okay too. Then you can develop it in the beginning like we did. So we want to know what the profit is. If X is 90, P is 400, C is still 278, and the fixed cost is 1945 still. Bed mass is very much alive. 400 minus 278. I'll show my steps here. 90 times 122 minus 1945 times 90. 10,980 minus 1945. So they'll have a profit of $9,035. They it will have a profit of $9,035. Cool. Hey, they're all the same. I know, isn't it great? Remember, we like tedious because it means we know what we're doing. So now, if they sell 100 barbecues through a special promotion, what's the minimum price that they could charge to break even? So now, again, we have to break even. Now they're only selling 100 barbecues. So now what's the price that they have to charge to break even? So again, we'll start with, I find it's easier to start with the blank one. Profit of X is X times P minus C minus the fixed cost. I don't know about you guys though. So now break even is when profit equals 0. So 0, X is now 100 times P, which we're trying to solve for, right? What's the minimum price that they can charge? Minus 278 minus 1945. So we have to add 1945 to both sides is 100 times P minus 278. $19.45 is P minus 278. So P plus 278. Oh, because I've already divided by 100.
Oh,
Is that
okay.
the one?
Yeah.
So 297.45. They must charge 297.45. All right. What market conditions would force Walmart to stop selling barbecues in the short run? So what I'm asking here is really, what's the shutdown point? Remember the shutdown point where it costs more to produce something than you can actually sell it for? Right? And so here I'm asking about the shutdown point. The shutdown point is when P minus C is less than 0, or if you prefer, when P is less than C, we have reached the shutdown point. Right. P is the amount that you can charge for something. C is the cost that it costs you to make it or to acquire it. Right. If the price that you're selling something for is less than it costs you to buy it, you got to shut it down, right? Because you're basically paying to sell stuff, and that is not good business. Okay. So P less than 278 they would need to stop selling barbecues. Nice. As far as an answer goes, That's all I'd be looking for. So I showed a bunch of other work, but that's all you need to say. Any questions about that one? It's from a long time ago. Feels like ages ago, but I think you've got it. So if we're having a peek at our list here, right, this is going to be the simple interest problem. Sure enough. You can just confirm it if you read, right? So I took out a series of loans. So blah, blah, blah on September 4th, December 12th, and February 13th. What total debt do I owe on June 6th, 2005? Assuming that I was charged 7.5% simple interest, right? So here you've got it on all of the short-term debts. Right? So this is just simple interest. Your calculator cannot do simple interest, so we have to do it by hand, but luckily the formulas they're not that bad. What's bad about this one, or what's hard about this one, is that we've got so many dates to keep track of, right? So when we're making our timeline, it's a good idea to just start and figure out how many dates you have, right? And that's how many ticks you'll have. So September 4th, December 12th, February 13th, and then finally, how much do I owe on June 6th? Right. So I've got four ticks. So up above, I'll just label September 4th, 2004. Oh, fun times. That was my first year of university, September. I was probably so nervous. Oh, fun. Oh, you see, yeah. North Campus, back in the old days. South Campus, North Campus, I know. It was just itty bitty back then. And then February 13th, it's like, where were you guys for these dates, I wonder? June 6th, 2005. So we'll start by putting all our dates up top and then the amounts underneath. So we've got 4,000, 10,000, 2,000. And then there's no amount on June 6th, but we want to know how much we owe on June 6th. We want to know the future value of all three of these on June 6th. Okay. And so because we're pulling all of these, right, to June 6th, that's going to be our focal date, right? Wherever we pull all our payments to, that's your focal date. So I start from the closest one. Gets a little confusing because it's the third payment, but it makes future value 1. Future value 2. Future value 3. And then add those up, and that's the total owed on June 6th. For simple interest, we just put the time on each of these arrows. Right? So we've got time 1, time 2, time 3. Time is always in years. Got to figure out how many days between these dates. You guys remember the days between dates function? Nice. So we'll start and say we need to find time 1. We'll start with that one. So remember, it takes date 1, date 2, oops, and the days between dates, which I'm calculating, so I'm going to throw a star beside it, using that same kind of notation that we have been using. The date function is month, month, dot, day, day, year, year. So date 1 for time 1, the way I have it laid out, is February 13th, 2005. So February is 02.1305. Date 2, what's nice is date 2 is going to stay the same for all of these, right? Because you're pulling all of them to June 6th, 2005. So it's going to be 060605. So find your date function. It's been a while since we were there, right? It's above the second function of over your 1 button. And then to change the date, so date 1 is 02.1305, enter. Otherwise it won't save it. Scroll down to date 2. I've already got it in there from yesterday. Days between dates, compute. I get 113 days. Making T1 113 out of 365, right? Because time has to be in years. Then we do the same thing. T2. Date 1, date 2, days between dates. Oops. Put an M in there instead. Date 2 is going to be the same for all of these, 06, 06, 05. December 12th, 2004, so 12.1204. If you're just sticking around in your date function, you can just scroll up to date 1 and change it. 12.1204, enter, and then scroll back down to the days between dates and compute. Yeah.
When we're doing a question like this on the file, do we have to do this to get marks, or can we just do it on the
Well, if you are very confident that you're getting it right and you just put it on the arrow, that's fine. But if you have done it wrong, then I can give you part marks if you show me what you did at least. Right? So
What if I just did it all in
not recommended. But yeah, so it's just a matter of the more you show me that you did, if something goes wrong, the more part marks I can give you. Versus if you're confident that you've got it all figured out, then as long as you put it on the timeline, right, then you're good.
For time sake purposes, like if we only had time to do just to put the days on each time, if they were all correct, we would lose marks.
Exactly. Yeah. So as long as it's all right, then fine, right? It's just if you are worried that you did it wrong, then at least if you're able to show me what you did, then I can be like, oh, okay, well, pretty good, right? So yeah, it's kind of a game. So I get 176 days. T2, 176 over 365. Yeah, because I know what you mean. The actually writing it down, I think, takes longer than what you're doing in your calculator, right? Because you're just flipping back and forth. But date 1, September 4th. 09, 04, 04. Is it 4th? Day 20665. Days between dates. Oops. 09, 04, 04. Enter. I got 275. Pardon? Oh, 7.5, which we'll just sneak in somewhere on here. Rate is 0.075. Nice. So for a simple interest problem, as long as you've shown all of this, right, you've got a complete timeline. And like I said, so if you want to just show this is your time and not show any of this, that's fine, but do it at your own risk. Okay, so now it's just a bunch of future values. Simple interest though, right? So make sure you stick in the simple interest part of your formula sheet. So future value 1 is, it's been so long, 1 plus P times 1 plus R times T. The principal amount for future value 1 is 2,000. 2,000 times 1 plus R is 0.075 and T was 113 out of 365. Okay. 113 out of 365 times 0.075 plus 1 times 2,000. I'll take it all the way. 2,046.438356. Or if you want to go to 2 decimal places right away, that's fine. Future value 2 is P times 1 plus R times T again. P and T change. 10,000 for 176 days. 1 plus 0.075 is 176 over 365. 176 over 365 times 0.075 plus 1 times 10,000. We would owe 10,361.64384. Future value 3 is P times 1 plus R times T. 4,000, I think. Oh, and 275 days. 4,000 times 1 plus 0.075 times 275 over 365. 275 over 365 times 0.075 plus 1 times 4,000. We would owe 4,226.027397. So let's look back. Well, we had to find the total owing on June 6th. So total owing is future value 1 plus future value 2 plus future value 3. Which is, let's see if I can have it on the same screen here. 2,046.44 plus 10,361.64 plus 4,226.03. 2,04644 plus 10,361.64 plus 422603. I get 16,634.11. Everyone getting the same thing? Great. So that's your simple interest problem, right? The longest part of it is just figuring out the days between dates, I think, and then just kind of cranking out those future values or present values or wherever the arrows are going to. Okay. If you look at our list, right, the next one on the list is, so we did simple interest, compound interest with unknown payment amounts. Right. Compound interest, unknown payment amounts. So we vaguely remember these. A contract requires payments of $3,000 and $7,000 made in 2 and 5 years respectively. So what 3 equal payments, right? So they're equal. We've had to deal with things like you make a payment and then double that payment a couple of months later, right? So now they're just 3 equal payments, one made today, one made 6 months from today, and the next one made 1.5 years from today. And they, of course, have to have the same value as the original contract, right? You're just replacing these payments. Assume that money earns 6% compounded bi-weekly. So we've got compound interest, and we're compounding bi-weekly. Don't be confused. This is not an annuity, right? Because an annuity is when we have regular payments, right? Every month we make a payment, every week we make a payment, every day we make a payment, right? Those would be regular payments. Here we're making a payment today and 6 months and then 1.5 years from today, right? So it's not a regular payment. So that's why it's just compound interest, right? And what I mean by that is just the first page of your formula sheet, right? The compound interest section. But we have these equivalent payments that we have to deal with. So first thing when we read through these, we're going to figure out, okay, how many ticks do we need? Right, so how many time points are we talking about? So the first contract was at 2 and 5 years. And then we're going to make a payment today, and then 6 months from today, and then 1.5 years from today. So I'm counting 5 ticks. So let's start there. And 1, 2, 3. Close enough. So now we want to list these in chronological order, right? And so let's start today. And then instead of saying 6 months, I'm just going to say half a year because all the other ones are in years. And it doesn't really matter, but it's just going to make it a little bit easier. 0.5 years and then 1.5 years. And then the final, or the original 2 payments were at 2 years and 5 years. So first I'm going to map out the original payments. And so I've got the original payments of 3,000 and 7,000 And then I'm replacing these with payments today at 1.5 years, and then finally at 1.5 or half a year, 1.5 years. Okay. So I don't tell you what to use as a focal date. So you could go to any one of these ticks if you wanted to, right? As long as all these, so these original payments are equal to the other 3 equal payments, it doesn't matter what date you go to. You could even make up a 6th tick. Not sure why you'd want to, but you could. Right? And so I'm going to pull them to today. I don't know. Seems easiest. How could you strategize it though? What if you prefer to calculate future values and only want to do future values? You'd have to pull all the payments to, because that would force you to make this a future value, that a future value, future value, future value, right? Whereas here, when I'm making it today, I have to pull all these to today, so I have to make them present values, right? So you can kind of say, well, I actually like to calculate future values, so I'm just going to pull all these to 5 years. Okay. What I think I'll do on the final is I'll tell you what to use as the focal date, because it makes it a little bit easier, right? Easier to mark, yes. But also a little bit kind of less guesswork for you guys. Okay. So I'm going to add here, use today as the focal date. What? I didn't want to calculate present values. Too bad. Too bad. Focal date. Meaning all my arrows have to go to today. So first thing I'm going to do is I'm going to figure out the value of the original payments today, right? Because that value has to be the same for my new payments, right? Otherwise they're not equivalent. And so I'm going to pull this little guy back, woo, all the way to make some present value 1. Whee. Present value 2. Adding those up would give us the total of original payments today. Underneath that, I would put my new payments, right? So my proposal is that I'm going to make a payment, some unknown payment amount X today at half a year and at 1.5 years. So the total value of these guys all pulled to today has to be the same as the total original value. So
when you get the total original value, you just divide that by 3.
no, we can't do that because these all have different amounts of interest owing, right? So we have to say, okay, well, this is going to be some present value 3, and this will be some present value 4. Mm-hmm. So this is the total of the new payments today. And I'll just say must equal total of original payments today. Just kind of making note of what we're doing here. So compound interest, let's deal with this rate first. So we've got a rate of 6%. So the rate is 0.06, and we're compounding bi-weekly. So the frequency is 26. So I is R over F, which is 0.06 over 26. Point 0.0023076992. I'm going to store this in one. So now, what we put on these arrows, right, for just compound interest, we put the number of compoundings, right? So here we have n is time times the frequency. The time is always in years, so it's 2 years, right? The length of this arrow is 2 years, times the frequency of 26. 2 times 26 is 52. Here we've got n is time times the frequency is 5 times 26, 130. Here I'll try to, n is time times the frequency, which is 0.5 times 26, oops, 13. N is time times the frequency, which is 1.5 years, times 26. 39. So now we've got a ton of present values to calculate. What's nice is the formulas are all kind of chopped up on the formula sheet, right? So you've got your present value. And so we can say the present value 1 is the future value over 1 plus I to the n, which for present value 1 had a future value of 3,000 and n is 52. So 3,000 over 1 plus, and then we'll just recall 1, right? But 0.0023076992. And yeah, if you want to write, just recall 1, I'll write. I'll allow it. Gone on the record. So then this is going to be, so we're going to deal with brackets first. So 1 plus recall 1 to the power of 52. And then 3,000 divided by that. I get 2,661 point. I'm just going to get lazy and just round to 2 decimal places right away. It's okay. Present value 2 is again the future value over 1 plus I to the n. Future value for present value 2 is 7,000 and n is 130. 7,000 over 1 plus 0.0023076992 to the power of 130. 1 plus recall 1 to the power of 130. 7,000 divided by that. $5,187, and just going straight to 2 decimal places, 52 cents. Let's keep trucking. Present value 3, again, is the future value over 1 plus I to the n. Future value for these guys, right now we're into the new payments. So future value is always going to be x, right? We're trying to solve for x. But we use that trick where we just use x until the end where we set them equal to each other, and then we can solve for it. N is 13. So x over 1 plus 0.00230769 to the power of 13. Do you guys remember how to get the, so you've got x over 1.03041892, but you want to bring that 1.03 up to the same level as the x? So I use the 1 over x button, or if you want to do 1 divided by 1.0304, that's fine too. But I get 0.97047907.5 times x. Same thing for present value 4. We've got a future value of x, 1 plus 0.00230769 and we had how many compoundings? 39. One plus recall 1 to the power of 39. I'll write it down here. X over 1.0940608838. Just using the 1 over x button, I get 0.914025953 times x. So now, right, we know all these values, right? We've solved for these values, we've solved for these values. Don't forget about this X payment here today, right? I always forget about that one because we didn't have to find the present value, right? But it's also part of this total, right? And so now we can say, okay, well, we know present value 1 plus present value 2. Oof, must be late. So we know that the total original, just using some kind of shorter notation, right? Total original payments today must be the total new. The total value of the original payments is present value 1 plus present value 2. And the total new payments is X, don't forget that little guy, plus present value 3 plus present value 4. So now we can substitute in all these values. I'll sneak them from here. So I've got 2,661.13 plus 5,187.52 is X plus 0.970479075X plus, I'll skip it down a line, ran out of space, plus 0.914025953X. So then on the left-hand side, we get 7,848.65 is equal to 2.884505028X. You should get the 2, right? Because you've got X plus a little bit of X plus a little bit of X. Right? So it should be close to 3. So X must be $2,720.97. Right, so these 3 equal payments must be $2,720.97. We'll keep going on this next day. See you then.